Hey guys, welcome to JacFab'in Friday, episode 5. This week, we get...
Overkilled.
That's right, I'm going to make a part for Will at Overkilled Motorsport. He contacted me about this guy. This is the lower intake manifold portion of an LGW 3.0 twin turbo V6. His experiment that he's conducting is he wants to swap the normal LGX intake manifold out for this guy, and I'm going to machine a plenum cover for this with an 80mm throttle body hole. Hopefully, the idea behind this is that this setup with your LGW lower and then the piece that I'm going to machine for the top will allow a more evenly distributed airflow to all 6 cylinders. So anyway, I've got the part designed already. I've still got to do the cam, so we'll hop on Fusion 360. I'll take you through the cam process. Hopefully that won't take too long, and then we'll just go straight to milling. Now, we're not going to mill the actual aluminum part today because this is a fairly large 2-operation deal. So what I'm going to do is make a test piece basically to verify that all the cam is right. We're not going to break any tools or anything. I'm going to be making that out of a PVC foam board. A lot of people call it Sintra. That might be a brand name, but it's used in a lot of sign kind of things. It's fairly rigid and it machines really good, so I kind of pirate a lot of scraps, stuff them in the corner, and then when I got to do a job like this or anything that I'm not real sure about, then I go ahead and make myself a sample piece first just to verify that everything's right and I'm not going to wreck a bunch of tools in the process. So anyway, let's jump on the computer, we'll do the cam, then we'll go jump on the mill. Okay, so here's the part that I've designed to suit Will's application. And when I first did the screen capture on this, I explained what all these holes are for. There's a blow-off valve hole, PCV, map sensor hole, brake booster. You saw the logo there real quick. I like to keep the logo turned off because there's so many points for the center points and the radiuses of the checkered flag that it slows the computer down. But anyway, there will be a logo on it. And here I'm going to change the stock for the stock that I have. But anyway, I pitched this center radius. It's a variable radius to Will on the exit of the throttle body because I was thinking in my mind that the larger radius on the front and the rear would allow the air to easily flow to the rear and front 2 cylinders because the throttle body is centered right almost over the middle 2 cylinders. So hopefully that will help more evenly distribute the air. And you can see there I've got a couple pockets that in my mind were originally for weight reduction, but Will had said, hey, that's great, that'll increase the plenum volume, and I was like, didn't even think of that, cool. So not only will it increase the plenum volume, but it'll also reduce some of the weight to the part. Not that it'll weigh a whole lot anyway, because it's aluminum, but anyway. I'd already done a couple operations on this when I had first designed it, but I'd made some changes today, so I had to redo some of the cam. And anyway, what I'm doing here now is basically hogging out the bore for the throttle body with a 1/2-inch bull nose, which I will use this 1/2-inch bull nose basically throughout the entire machining process because I'm trying to use as little tools as possible. But that bull nose is going to give me a real nice radius on that exit for the throttle body with a small step over. There I just did a real quick 2D contour for the throttle body exit for the finishing pass. And And you can see that I'm dropping the bowl nose below the part because it's got a radiused edge, and we don't want to leave a lip on there, so you got to drop that down. Here I'm picking out all the small holes that we're going to drill with a 199 drill bit, and we're not going to use that for the final part made out of aluminum, but I need to tap some of these holes for the ghetto fixture that I'm going to use. So here I'm picking out the large drill bit that I have on the machine that I'm going to use for all the larger holes. And right here I'm stealing the tapping operation from one of the parts that I make for the LTG, just because I hate doing the math on the tapping. So once you got it figured out, I just copy it, steal it for the next part, because I generally use the same tap when I'm trying to hold things down, and most of the stuff's metric anyway and M6, so I just steal it. So right here what I'm doing is I'm picking all the edges for the chamfer tool. I'm going to chamfer all the holes, pockets, and you'll see that I kind of make a mistake a little later on that. Chamfer ends up being too big. But anyway, the final part of the process here is I'm going to do a 2D adaptive using the bowl nose again. Go down as far as I can, as close to the vice jaws as possible, to clean up that edge and remove the excess stock. So what I'm doing here is the 2D contour for the finish pass around the outside. I'm going to use the same offset as I did for the adaptive clearing, so I can not hit the vice jaws while I'm doing this. And then, since this part is supposed to be 3/4 of an inch thick and I've got 1 inch thick material, it occurs to me that I need to do a face pass to remove some of that excess material. So I'm just going to do a quick face pass here, and then I'll drag that up to the top for my first operation. So it's going to remove all that excess material. And then I think we're going to post this and we're going to go mill. I'm surprised I didn't do any talking before I did this, but what we're doing here is we're going to probe. We just probed the Z-axis right there. And right now we're going to probe the X-axis with the Renishaw probe. We'll do the Y-axis, and this will be the bottom side operation. here we are machining the bottom side. And I don't think I'm really going to talk too much while I'm doing this because I've got these machining operations sped up so fast that it's hard for me to even see what's happening and to even explain what's happening. Got the GoPro at a little different location. The last time it was in the mill, and it's a little better, but as you can see, it's still not great. So hopefully in the future, as I keep doing this, I can get some better GoPro footage. But anyway, this is the bottom side. Enjoy. I guess I should also mention that while you're seeing this in approximately 3 to 4 minutes, the bottom side of this part actually took a little over an hour to machine, and it's probably going to take even longer in aluminum because I sped up a lot of the feeds while I was doing this because I knew it wasn't in aluminum. And when I did the cam, I didn't change any of my feeds and speeds because I didn't want to have to go back and redo it later for the aluminum part. So my feeds and speeds are basically sped up for aluminum. Or not sped up, but anyway, they're set for aluminum. And anyway, I didn't want to have to go back and change them when I redo this part in aluminum. It's already set up, and all I've got to do is fix my little mistakes and then put some aluminum in and we're off and rolling. Okay, we're done with the first operation. Boom! Looks pretty good, right? Yeah. So, there's a reason I do test pieces for things like this. You can see the chamfers on the holes, way too big. So, I went back and I changed the chamfer size for the outside dimension. And you can kind of, hopefully you can see this, but this is what I was looking for. Right? So anyway, no big deal. You can also see on some of the holes, it didn't chamfer all the way around with this big dumb chamfer. That's because it was a big dumb chamfer and the tool offset wouldn't physically allow it to do so. So with the offset and the chamfer size changed to get this nice just edge break chamfer, that's what we want. That's going to be great on the next aluminum part. Aside from that, I don't see any other problems with this. There's a couple areas that I'm not 100% certain if it was a problem with this material or the tool path itself, but it's too close to tell because this stuff isn't metal. So as you remove all this material, it's gonna start to go like this and like this, and especially because it was clamped in a vise. And so as it was clamped, it's gonna start doing this and that. But anyway, for a test piece, this is great. There's nothing wrong with it. You know, we fixed our little problems. And check out this radius. Boom! That is sweet. And hopefully the GoPro caught some footage of the coolant draining down this thing like a toilet. I was just standing there at the mill just watching it going, dang, look at that airflow. Woo! But anyway, so this is done. I'm gonna go ahead and cam the top side. We'll run the top side and we'll call it a day. But anyway, I'm super happy with this, regardless of my little mistake. Not a huge deal. It's an easy fix. So that's why I run test parts. Because can you imagine sticking a 1-inch piece of aluminum block this big, right? Billet, and then getting this and be like, dang, well, I just ruined $100 worth of aluminum there, sweet, and wasted hours worth of time. But this is free scrap nothing, so it's not a big deal. And the final piece is going to look amazing. So anyway, bam! So once again, I did the voiceover for this while I was recording, and it was so long that I just decided that I'm gonna speed it up because you're not gonna want to watch this for 20 minutes. So anyway, so I did a quick face pass there. I'm gonna do the O-ring pocket here with an 1/8 inch end mill. So right now I'm doing all the counter bores for the socket head bolts with a 3/16 end mill. So I'm going around and picking every single hole that's going to be counterbored. And right here I'm going to drill the mounting holes for the throttle body and the map sensor. And then we're going to tap those holes with the tap. And we're going to chamfer everything with a smaller chamfer than our problem chamfer that was too big on the bottom. Thankfully, there's not a whole lot going on here on the top side. No random pockets or anything. So we're going to do a 2D adaptive to finish off the OD and a 2D contour to finish that. And then we're going to do our corner rounder, which I'm going to steal out of another part that I know corner rounder works well with aluminum. And finally, there's the logo, which we're going to do with a 080 ball mill. And now we'll jump back to the mill and do the top side. So here we are milling the top side. And what was once 20 minutes is now 2. Because I know you're not going to want to sit here and watch this for 20 minutes. And it's flying by so fast that I can't even explain what's happening. So anyway, enjoy the fast-paced machining with the poor GoPro footage. All right, so we just finished machining the top side. Boom! There it is, boys and girls. Anyway, you can see the
Overkill
logo right there. That turned out super good. And you can see that I did learn my lesson from the last time on the chamfer tool. The chamfers are perfect in the center of the part. As they go towards the outside, they get bigger. That's because, like I thought earlier, as I remove material from this, it goes like this. So, granted, this is still pretty good, and I'm super happy with it, especially for having a ghetto fixture that I removed and then put back on, because trying to pick back up on a ghetto fixture is super hard. But for a ghetto fixture, when Will first started talking to me about this, you know, obviously he didn't say he wanted to go into production with it, and I figured he probably didn't want to either. So I said, yeah, I'll make a ghetto fixture. And, you know, this is basically, it's not really a one-off, but it's kind of a one-off, because I don't know if he's going to want to make more. And the ghetto fixture isn't that great for production parts. So basically, if you look real close, you can see, I don't even know if you can see this, but there's a line that's, you know, maybe, I don't know, 10 thousandths or so, that kind of comes across here and there when my phone's ringing. And now it stopped. So anyway, there's an ever so slightly visible line from the top to the bottom where I did the adaptive clearing from the bottom to the top. So, you know, I wouldn't feel horrible about selling this to anybody, but in a production setting, in a perfect world, that line wouldn't be there. But it's so barely noticeable that, God, I just feel great about this. The logo turned out great. You know, I wasn't real certain how good the word superchargers would turn out, just based on the logo that he sent me and how the I don't know, CAD conversion turned out. But it just looks super good. The logo looks great. The chamfers, a lot of the problem with that, you know, I've already fixed. Should probably stand back here. I've already fixed a lot of the problem with the chamfers, and the problem with them getting smaller versus bigger on the ends, that'll go away, because when I use aluminum, it's not going to curl like this thing did. And if you look real hard, you probably can't see it, but it's ever so slightly goes like this. And that's just because of the material and how much material was removed. It started out as a 1-inch thick piece, and I took it down to 3/4 of an inch and counterbored all the holes. The only mistake that happened on the top side, which again might be, yeah, okay, I don't feel so bad now. Okay, so the corner rounder, you see I took the corner rounder around the whole OD of this thing. It's dang near perfect on the center, and it's maybe, I don't know, I could probably raise it up about 5 thousandths, 10 thousandths tops, and it would just have a perfect corner. But on the edges where it's curled, you can see that there's quite a step there. So I was disappointed at first, but the more I look at it and I realize that it's not my fault and it's not the mill's fault, it's the material and the ghetto fixture. If I had a fixture for this thing that went full length, so this thing didn't bow, then it would be perfect. But it's a ghetto fixture. I was only using these 4 center bolts to hold it, and you know, I can't complain. The only thing, I've already fixed the chamfer problem on the bottom, and the chamfer tool, you know, I'll probably add, say, 20 thousandths to it, and I'll creep up on it when I do the aluminum one. But this thing is, it's good. It's ready for production. So anyway, that's the JacFab'in Friday of the week. And Wheel It Overkill, I know you're watching this. I hope you love this, because I love it. So anyway, boom! That's all for this week's JacFab'in Friday. Thanks for watching. And if you like this video and what I'm doing here, be sure to like and subscribe to the channel, because I'm going to be making a lot more stuff like this. So, peace out.